Hello everyone, in this video we are gonna show you some stuff about the BGP, mainly for BGP process to establish the connections each other, BGP Finite State Machine. Why BGP? BGP because BGP is the most important protocol network, I guess. It's the protocol that's carry the internet. It's a scalable protocol. There are control policies, good control policies. It's granularity to handling with that, and that's why I decided, because I already faced it for something similar. In some cases, you spend or waste more time than expected because you don't have the properly knowledge about this process. This process might be useful for you during your activities, inclusive to solve and fix the problem. BGP FSM Finite State Machine. It's composed by six steps. Let's describe it here. I'm going to present as we have here. BGP Finite State Machine. We've got 6 states: idle, content, connect, open send, open confirm, establish, and active. The number one is the idle. It's the process where the routers is trying to identify if some event was registered or if something gets happened, to start or moving to the next state. Second state is connect. Connect is the steps to establish the handshake, where the routers send the message type SYN, and the second equipment who has that's received these messages send back this answer saying flag acknowledge, SYN acknowledge. Imagine that we have 2 routers, router 1 and router 2, and then both of them, imagine the router 1 start the process. I'm going to send the message type SYN, like asking, okay, I want to chat with you, do you agree with that? Okay, the other equipment, the router 2 receive these mentions and say, okay, I received your SYN and I'm gonna to give my answer like this flag, SYN slash acknowledge, ACK. Okay, so after this process, we receive the acknowledge message to establish the connections with each other, with router 1 and router 2. But it's the concept about TCP. It's not the proposal for this video, but I can do it, or I can describe it in another video, just to give you an overview about this process that's involved in BGP Finite State Machine. Active mode, where the BGP is actively trying to connect and to negotiate all the parameters to proceed to the next step, trying to make TCP sessions with the neighbor. As I said, we have here also open send, where we have both nodes, as I said, router 1 and router 2. We have, imagine in my case, my name is Ailton, I am 33 years old. In the other side, we have the other equipment, that's the name is John. John has the John say the same for me. My name is John and I am 33 or 34 years old. Imagining that we have the parameters that delimit our connections. For example, lower than 30 it's not possible to establish. Imagine the John has the 28. I will not be able to establish the connections. It's like this for OpenSend. The OpenSend exchange the messages for both routers and perform the match. If everything's going well, we can move on to the next step and send the message to confirm. The confirm is the next step where I already confirmed those informations about the match as we have here. Both sides we have said hello and confirm those parameters. I'm going to describe it all of these parameters like AS number. We have also IP or many things we have. Timers we can validate it, but I think so the keep alive that's responsible to validate that. This is the responsibility to the next state that is established here. Established process. That's the process where we have the exchange of routers, updates. Imagine now I'm going to announce one information to John. Oh, John, I've got the news and I would like to say something. And John, we are gonna to receive this information, this update in this state established. And then we'll describe it how this message across the path and how we can identify this message when and which flag we use to identify that. Okay, that's it. And then let's go to our lab. So as we can see here, we are using the IBGP. It's not expected to have the different AS number. Okay, this is the router 1, router 2. We are using the transit loopback also. I'm going to describe why we are using the loopback. Let's see the router 1. We already saw the router 2. That's the transit for the router 2. Transit for router 1. It's right. Loopback. Why loopback? Inclusive. This will be used by BGP as router ID because BGP prefers to use the loopback because the loopback it's more reliable. Imagine that we have two interfaces, but if some physical interfaces goes down, we are gonna be sure that the loopback it will be up. Okay, as we can see, the BGP it's not active. There is no config. In our case, we have here the base config. I can let this in our description of this video. As we have here, we've got the configurations. Let's copy and paste. Okay, and put the configuration there, router 1. Let's do it to the same to the router 2. Okay, let's capture because we are looking for the message to describe and inclusive the finite state machine. Okay, copy and paste. Now let's see. Okay, we can see any messages about BGP. Let's just to adjust. Okay, let's copy. Okay, as we can see here, we've got all the steps about the finite state machine that we we are looking for. Okay, great. Let's describe all of them. Okay, here we've got all the messages about the finite state machine. Okay, but we need to have a look. But as we can see there, from idle to active, from idle to active. Oh, open send, open confirm. As we can see, from open confirm to establish as expected, and I described it previously. The session has been up. Okay, we've got one prefix is announced, the neighbor of the router that we have the session established. Now let's have a look on the router 2. Okay, let's just to adjust it to my window. Okay, show IP. Okay, show IP BGP summary. So as we can see, we've got the session established and the one prefix is announced. Router 2. Let's have a look on the capture. Let's have a look. Okay. So as we have here, there are the router 2 trying to connect router 1, update messaging. Okay, let's clean up. Let's capture again, because I'm looking for to follow all the process, all the messages, to give you a pretty context about the finite state machine. I'm going to remove all BGP settings and trying to configure it again. Now the BGP goes down, went down. Let's check. Okay, so let's copy and paste this. Okay, so as we can see here in our capture, that's nice, pretty nice. We can see the TCP for trying to connect as I described it. Okay, now the source, destination IP, the version, it's some fields that use it for the connection part. Okay, our destination port, the type of flag that we are using, which IP we are using. We've got the SYN acknowledge, in this case the answer received for the secondary router, the protocol that we are using for that, who is the source, destination, and source port, and destination port. Destination port is a random port, that's not relevant for this topic. That's nice, great, as expected. Look for this flag after to negotiated all those flags. SYN up. We've got the acknowledge flag to establish the connections. For TCP is the process involving the connection, the connect state, BGP, the BGP connect state. Okay, open send. This process, as I said previously, is the process where we are gonna check the AS number that your neighbor are using, holdout time, as I described it previously, and the BGP identifier. In this case, we are using the loopback because, as described, BGP prefers use the loopback because loopback is more reliable, and we've got the more resilience using the loopbacks. That's nice. Great. When we have this knowledge in our mind, when you have some problem or some message about BGP during the process to establish the connections or something like, you will be able to perform the quickest troubleshooting. You will be able to solve the problem, perform the logic steps. Keep alive. After to receive the keep alive, the BGP gonna be establish the connections. Great, as described. Okay, after to receive the keep alive, the BGP moving the steps to establish the update message. In this message, we've got the messages like new routes or possible routes that we wish we draw. For example, I want to remove one router, and then we are gonna see this message over there. Let's simulate it here. Okay. And router 2. Let's just show so I can some details here. I'm gonna I want to start a new capture just to clarify those topics. The next stop and the next topics. 1 second. Let's have a look. Which are the current configurations, just to be sure. Show run website BGP. Okay, great. Now we are announcing just one network. Let's have a look. Capture is started. Okay, nice. Great. Let's have a look. Okay, now we are gonna to change the AS number because I want to simulate it, the issue, the problem using the different AS and where we can identify that. Okay, now let's see. The BGP are presenting some information, so the send notifications, different messages, as we can see. Okay, capability, the BGP is complaining about something. Well, idle to connect, BGP moving the phone idle to connect as expected. First step, idle to connect, and then on active version, the BGP is performing the validations, but as we can see in the highlight, the remote AS that's complaining, that was expected 6,000 65,000 in this case. Let's have a look. Okay, we've got all the steps that's working, but as we have changed the BGP AS, the session that's not working. The session cannot be established. Okay, notification message, as we can see there, over there. 1 second. Let's show. Let's see. Okay. Or SAC BGP. Okay. Let's confirm the other side. Configuration. Router BGP. Now we are gonna to adjust it, remove and add the right information, and to follow the process about OpenSense. That's why it's pretty important to have this info fix in your mind. Great. That's nice. Oh, we just remained that, and then as we can see, SYNAC. Let's have a look. Okay. IP BGP summary. Okay, now the BGP is up and running. Right. Up and running. Let's see on the router 2. Right. Idle to active. It was on idle, went from idle to active local address, actively trying to connect. That's nice. Okay, we can check the IP that we are using for transit. It's the same process, but now we've got the right AS, autonomous system. Okay, because before we were using the 65,001, I think so. Oh, the whole time it's right. We've got the match. Great. Keep alive message. Keep alive message. And after to receive the keep alive, we've got the update where we can see the network reachability informations. These messages carry updates or withdraw when you have some updates to remove some networks. I will describe that. Now we've got just one, but we can simulate it. This message, type of message. When you have this in your mind, you know, when you have a look and you see the message update, you already know that you are talking about the possible update or announce or withdraw network. Let's see. Okay. I want to start the new capture. Let's have a look how many loopbacks we have. Okay, let's configure. Okay, now we've got the 2 loopbacks, and then we can announce a new loopback just to simulate. Let's see. I'm going to announce that loopback. The proposal is to have this information pretty clear in the packet capture. Okay. Okay, great. Capture. Let's capture. Great. Okay, that's nice. Okay, done. Let's see. It measures. That's nice. It's pretty nice. Let's have a look. Path attributes. Next hole. but we are looking for that. As we can see, we've got the new networks up and running. Okay, when you announce the new network, or if you decided to remove, you need to have this message fixed, or keep this on your mind. As we can see, we've got the two prefixes.